Thank you for joining me for this FlowLogic 8 webinar. In this demonstration, I'm going to give an overview of FlowLogic and demonstrate a typical analysis workflow. I'll show some of the tips and tricks and highlight some of the new features in the latest versions of FlowLogic. So FlowLogic is a sophisticated flow cytometry analysis software. It combines FCS and MQD file gating tools with the ability to graph results, perform statistical tests, and generate reports. All sections of the software are linked, so adjusting a gate will automatically update all elements of the analysis right through to the report. So whether you need to do complex immunophenotyping or high throughput screening, or either cell cycle analysis or proliferation analysis, or even a multiplex bead analysis, the tools exist within FlowLogic. There are also auto-titration analysis and auto-compensation tools, along with an inbuilt end-to-end cluster analysis package. It is also possible to determine the EC50 or IC50 following a regression analysis, and a QC check can be performed to identify any potential differences in the saved compensation matrices or differences in the PMT voltages within a dataset. It can also be used to extract events recorded at an optimal flow rate. So I hope that gives you an idea of what is possible within FlowLogic. And if you do need to use some of these advanced features, please refer to the detailed instructional videos on our website. So now I'll move on to the introductory live demonstration of the software. Before I begin, I want to highlight that FlowLogic is compatible in all operating systems. So it's the same piece of software that works in Mac, Windows, and Linux computers. That means that you can start your analysis in a Mac, save it, and open it in a Windows computer, and everything is preserved and you can continue your work. FlowLogic also requires Java to be installed on your computer. In general, we recommend installing the latest version of Java if you're running the latest version of FlowLogic. But please see the FAQ section on our website for the most up-to-date information. It's also worth noting that if you're using a floating license, which acts as a virtual dongle, you can release your license from within FlowLogic or even from your online account. This means sharing your license between different computers or different users is very easy. Once again, an example, if you're working on your work computer, you quit FlowLogic, you go home for the day, and then you decide you want to use your license, but it is currently linked to a computer at work, you can log on to your online account, release the license remotely, and type in your username and start analyzing your work at home. Within FlowLogic itself, there are two main analysis file types I'd like to highlight. For example, if I clicked on File, Save As, I would have the options to choose a GLF or a GateLogic experiment file. The GLF saves all of your analysis gating, heat maps, graphs, and report elements and links them to your FCS or MQD files, whilst the GateLogic experiment file will compress all of your analysis attributes with your files into a single analysis file. The GLF is a very small file and quick to save, but if you move your FCS or MQD files, you'll have to relocate them and link them back to the GLF when you open it. The GateLogic experiment file, because it's compressed all of your FCS or MQD files into this analysis file, it will be a much larger file, but no matter where you open that file from, all the information is contained. So if you were sharing an analysis file between different people, the GateLogic experiment file is probably a more flexible file type. Now I'd like to give a very brief overview of FlowLogic. Here I am obviously working in a Mac, so some of the positioning of buttons and the general look and feel might be slightly different if you're in a Windows computer, but all of the elements will exist in all operating systems. FlowLogic itself is divided into four main sections. Here we have GateLogic, where we import files, add our gates, create overlays, generate heat maps, and calculate statistics. GraphLogic, where we can add our data to spreadsheets and graph the results and perform statistical tests. DocLogic, where we can generate reports with all elements from any part of FlowLogic. And BeadLogic, which is an integrated multiplex analysis tool. Within GateLogic itself, the main components are the file navigator, where we import folders containing files, the file inspector, where our files will be listed, our plot workspace, where we can view our dot plots, histograms and overlays. And below the workspace we have our advanced functions. So this is where we can perform cluster analysis with FlowLogic, quality control checks with QCLogic, generate heat maps with FlowLogic, set and view statistics, view all of the parameters contained in the file, perform auto-compensation and calculate a spread quantification index, view all the metadata contained within your files, view the compensation matrix, and assess the statistics calculated as a result of cell cycle, proliferation, or other curve fitting analyses. And finally, before I begin my analysis, I will highlight the program preferences. These are contained within the Edit menu under Preferences. And you'll see the main preference topics listed down the left-hand side. For example, under General, we have some plot visualization settings. There's also the option to warn before closing FlowLogic, allowing you to save your analysis, automatically release your license before closing FlowLogic, and also enabling undo. Within the parameters settings, the main options will be adjusting your default axis range settings and choosing the specific parameter labels that you wish to display. For example, the user labels which you created at the time of acquisition. Under Export, you can choose which attributes for a plot are exported with the image. The palette shows the colouring for your density plots. You can change these or select a different palette from the drop-down menu. You can have some default settings for the user interface. You can set the amount of RAM that FlowLogic will utilise in your computer. However, in the current version, FlowLogic automatically detects and uses the maximum amount of memory that is available. There are some default settings for FlowLogic and also overlays. I'll begin by importing some files, and the easiest way to do this is to click and drag a folder containing files and drop it into a project. So the file navigator contains these folder structures. We have project folders, and within project folders, different experiment folders. You can right click to add new projects or new experiments. You can also click and drag files from one folder into another. When you use drag and drop to import a folder, the new experiment folder will take its name from the original folder. We can also see the file count within this folder. Here we have our list of files that we imported, and to view a plot in the workspace, I can simply right click, choose plots and open, or quickly double click. Plots in the workspace can be resized by clicking and dragging a corner, or using the adjustment slider at the top of the file navigator. Above the workspace, we have our different gating options, followed by our different plot display options. So to add a gate, select the plot, click on one of the gating options, in this case a polygon, and click to add nodes to draw your gate. Here I will right click to close it, and you can give it a name at the time of creation. I'll also click and drag to reposition the gate label. Gates can also be renamed by selecting them in the file inspector, right clicking and choosing rename and typing in a new name. Polygon gates can be adjusted by clicking and adjusting a node, clicking and adjusting an edge, or by clicking within the gate to reposition it. To open the child population, double click on the gate name in the file inspector or within the gate in the workspace. Then you can choose new combinations of parameters or even a new plot display in the workspace. And here I'll add a histogram marker to my histogram. I'll very quickly add one more gate to this granular site population, in this case an elliptical gate. If you wish to delete a gate, you can make the selection within the file inspector, right click, choose delete and rows, or you could highlight the plot, highlight the gate, and click on the trash can icon in the toolbar. As mentioned, to change the plot display, simply highlight the plot and click on the different plot display options in the toolbar. There are standard density plots, dot plots, contour plots, pseudo color plots, and then combinations of these different plot types. If you wish to copy a gating hierarchy from one file to another, select the gates in the file inspector, right click, choose copy, and copy gates. Select the new files, right click, select paste, and gates. Alternatively, you can copy by selecting and dragging a gate selection onto a new file, and you can even use this method to drag a gate from one level of the hierarchy to another. You can also copy gates and choose to paste to all in one go, or even right click on the folder and choose either paste gates to folders or paste gates to folders and group. So in this case, I'll paste my gates to all files in the folder. A gating hierarchy can also be saved as a gate template. You can do this by right clicking on the file containing the gating hierarchy, choosing template, gate, save gate template, and then on your new files or datasets, highlight the files, right click, choose template, gate, and apply gate templates. An alternative method for analyzing multiple files is to perform a group analysis, which is my preferred method. To demonstrate this, I will first delete all my gates by right clicking on a file, choosing delete, and all gates or all gates and clones. So group analysis means that any action performed on one file in the group will automatically be applied to all files in the group. To create a group, highlight all of the samples that you wish to be grouped, right click, choose group and add to new. This will give a color coding signifying that these are all in the same group. In this case, I want to go one step further and also display my analysis overview in a plate within FlowLogic. So here I'll click on the FlowLogic tab. I'll right click on my folder containing files and build a special type of plate called a plate with images. So here we have a special plate with one file per column, and it will eventually have one level of the hierarchy for every row. Initially it looks a bit difficult to read, but it will all make sense soon. I also want to open the plate side drawer and choose to remove the plot headers, labels, and axis markers. Now I'll open the first sample in my analysis, change the parameters, and start building my gating hierarchy. And you can already see that any adjustment I make to a plot in the workspace is automatically updated within the plate. Now, as I add another level to my hierarchy and start adding additional gates, the plate will start to grow. So I'll add a few more gates to complete this hierarchy, but I'll skip forward, having added a histogram marker and another rectangle gate, and I'll gate on a further 3 populations at the end of our hierarchy. So here we have a granulocyte population, a monocyte population, and if I change the x-axis parameter, I can identify a macrophage population. So I've now finished building my basic gating hierarchy. We can see all of the plots from the first sample, and within FlowLogic we get an overview of all plots in the analysis. We can gain greater insight into our populations by opening the plot side drawer, And within the gate list tab, we can perform live coloured backgating. One little tip: if you wish to return to the combinations of parameters where a gate exists, simply click on the gate name and the combination of parameters will switch automatically. It's also possible to turn off gates without having to delete them. But in this case, I want to give my populations a colour, so I'll select a new colour and simply tick the box in the on column. And you can see now this granular site population is coloured purple at all levels of the hierarchy. We can very quickly colour all of our populations and display them at all levels of the hierarchy, and as we have our populations displayed in a plate, we can see these populations for every single sample. This coloured backgating also updates in real time, so if you move a gate, you'll see that the populations at all levels of the hierarchy will update accordingly. And as soon as you drop the gate, everything in the plate will update automatically. There are also many tools available if you wish to assess your plots in more detail within the workspace itself. So here I'll hide my advanced functions drawer, and in this case I want to display all of my populations within the workspace. One useful tool is to highlight the particular populations that I want to visualize from one sample, right click, choose rows and highlight level. Then I can right click, choose plots and open. And this will open all plots in the workspace. From here it's very easy to scroll through and check all plots. The workspace itself is dynamic, meaning that any particular plot can be expanded individually or moved around. But at any stage, if you readjust the size using the slider, everything will snap back into the order as defined by the rows in the file inspector. It's also possible to change the number of plots that are displayed horizontally. So for example, if I close all plots, if I only wanted to display the first 4 samples from every file, when I open these in the file inspector, it is very difficult to separate the individual files. However, if I go to Edit, Plot Arrangement, Number of Windows, this is where I can define the number of plots that are displayed horizontally. If I click 4, then we once again return to a format where there is one sample per row, and it's much easier to compare the different populations from every file. Another advantage of working in groups is that if you adjust a gate on one sample, it will update on all other samples in the group. However, if you wish to adjust a gate independently, you can remove one or a selection of populations or complete files from the group. So if I want to remove this live rectangle gate from the group, I can select it from the file inspector, right click, choose group and remove. You'll see the colouring has disappeared, and now if I move this gate, none of the other corresponding live gates will update. Likewise, you can create additional groups. So if we wish to group these 2 gates, we can highlight them in the file inspector, right click, choose group and add to new. These will be assigned a new colour, indicating that they are grouped together. So now just these first 2 gates are grouped, but these remaining CD11B positive gates remain grouped together. And of course, it's possible to return everything to the original group. In recent versions of FlowLogic, additional tools to help visualize different samples have been added to the file navigator. To demonstrate these, I will close all of my plots and reopen the first 5 populations from the first sample. Now, if I wish to view a different population, I could choose the jump on click option, and now as I click on a new file, it will repopulate those samples in the workspace. So I could jump right down to my last sample to refresh the view. I could also pin this selection of plots to the workspace by displaying the plots in the workspace, clicking Default Plots, and now if I open a second selection of populations, the first row, being in this case sample 1, will remain locked to the workspace, but if I was to once again choose the jump on click option and click on a different sample, only the second row will update. It's possible to pin multiple rows to a workspace. For example, you might have the first 2 samples or one example from different experimental groups. Deselect default plots, once again tick the selection while they are displayed in the workspace, open a third population, and now if we again choose jump on click and click on a new sample, only the third row will update. So it's a very useful way for visualizing and comparing different populations when you have many files. It's also very easy to generate overlays within FlowLogic. Here I will once again close all of my plots, and to generate an overlay, simply select the populations from the file inspector that you wish to be included in the overlay, right click, choose overlay and new overlay, and by default a dot plot overlay is created with the samples that were selected. But this plot acts like just any other plot, meaning that you can change the plot display from a dot plot to a histogram overlay, change the parameters, right click for more formatting options such as smoothing histograms, or in this case adding colors to our histograms. Within the overlay side drawer, you can reorder the samples by dragging and dropping, or tick to hide particular populations without having to delete them. You can also gate on overlays and open the daughter population as an overlay containing the same samples. And overlays are contained within the pull-up window at the bottom of the file inspector. Now that we have performed our basic analysis, it is time to generate some statistics. To do this, select Set Statistics from the Advanced Functions drawer, and then you will be presented with a selection of population-based statistics and parameter-based statistics. And it's just a matter of ticking the corresponding box with the statistic that you wish. For example, if we wanted the event count for these 3 populations, then click on the View Statistics tab to see the results. Now these results can be exported as a CSV or an XLSX file, or we can import them into FlowLogic, which I'll demonstrate soon. These statistics will also update automatically with any adjustment to gates, or if you make a different selection within the Set Statistics tab, then we will get the updated selection in the View Statistics. If you wish to calculate a median or a mean fluorescence, highlight the population that you're interested in and tick the corresponding parameter-based statistics from the panel on the right-hand side. So if I wanted the median fluorescence for APC for this population, I make my selection, and then the result is displayed in the View Statistics tab. So now that we've performed our basic analysis, it's time to graph our results, perform statistical analyses, and generate a report in FlowLogic. So now I'll go and click on the FlowLogic tab, where we are presented with the FlowLogic spreadsheet, the workspace where graphs are displayed, our file inspector with the gates hidden by default. They can actually be displayed, but the general workflow is to make the population selection within the spreadsheet. And at the top of the file navigator, we have access to the different components from within FlowLogic. So we have our list of FCS files, our list of plates, our view statistics tables, and components from a B-logic multiplex analysis. In this case, I'm only interested in graphing results from our FCS files, So I'll select the Gate Logic tab, and I will import my samples into the spreadsheet in their experimental groups. So here we have an N of 5. I'll highlight my 5 samples and drag them anywhere into the spreadsheet. You'll see as soon as I drop my selection, I'm presented with this table structure, which has a table name, a group name, column counts, and then these are the actual data fields linked to the FCS files. Now I will select my second selection of files and drag them into the first row immediately below the existing data. From here I can quickly perform some formatting. So visually you might want to choose a new color. You can rename the groups. In this case, I'll name the table my monocytes percentage parent. And from here, we can update the presented statistics by highlighting the linked data fields and choosing a population and statistics from the drop-down options. So in this case, it's simply a matter of choosing the monocyte population, and I wish to present and display the percentage of parent. Of course, I could choose an event count or a median fluorescence for a different parameter. Once I have made my selection, I can quickly graph my results by highlighting the table and dragging the selection into a workspace table folder. The table folder itself is automatically renamed by way of the title in the spreadsheet. And I can click on the Graph tab to display my graph in the workspace. Graphs in FlowLogic can be easily formatted using the formatting panel at the right of the graph workspace. To update the formatting panel to reflect the specific component of the graph, click on the different portions of the graph or any of the keywords in the corner of the plot. For example, clicking on graph type will display all of the different types of graphs that are available, and simply click on a different option to update the graph in the workspace. You could also click within a portion of the graph, such as within a bar in this case, and choose to recolor the bars. Click and drag to reposition the legend or format any of its attributes using the formatting panel options. You can click on graph labels if you wish to change the direction that they were displayed in, and even click on any of the titles or labels to change the font type, style, size, or color. You can even edit the title and label names using the text field in the corresponding formatting panel, or if you wish to remove a title or label completely, just clear out the text from that particular text field. For more information on the different components of the graph that can be edited, click on the Info keyword to bring up this window highlighting the different portions that can be formatted. Once we have graphed our results, the next step is to perform statistical analyses. So here, click on the Analysis tab, choose an analysis group, in this case a t-test, a type of test, I'll choose an unpaired t-test, tick to select the groups to compare, and then we get our results displayed in the table to the right. We can return to the workspace at any time by clicking on the folder containing our data, and you'll see this automatically highlights the selected information. The power of FlowLogic comes with the ability to very quickly analyze additional populations after performing the initial analysis on one population, as I've done here. To demonstrate this, if I want to graph my other two populations from my analysis, I can use keyboard shortcuts or the right-click menu to copy, paste, and paste. Here I will change the title of my tables. Change the selection by highlighting the data and choosing a new population from the list. And because I've already performed some formatting and editing to my graphs, I can right-click on the table folder, clone the selection, I'll clone it again, and then simply drag my new data into these cloned table folders, choose to replace the existing data, and you can see very quickly we have graphed all three populations. Of course, it's possible, if you wanted, you could copy the full selection of data, highlight the values, and choose a new statistic from the drop-down list. Once again, you can very quickly clone the graph tables, replace the data, and display the results graphically. I mentioned that the results from the view statistics table can be imported into FlowLogic. And so we can do this by clicking on the Statistics tab in the File Navigator, choosing the specific statistics table linked to a particular experiment folder, and clicking and dragging it into the spreadsheet. And you can copy, cut, paste, and reformat this any way you wish. The spreadsheet in FlowLogic can also be exported by right-clicking, choosing Export Table, and choosing either a CSV or an XLSX file. From here, if we wish to generate a report containing any elements from our analysis, we can click on the DocLogic tab. Within DocLogic, we have our page. Above the page, our formatting toolbar. To the left, we have our File Navigator. And to the right, we've got our list of documents sitting above the page preview, which also doubles as our element formatting panels. Elements generated from any portion of FlowLogic can be accessed from the icons above the File Navigator. So we have our list of populations and overlays from GateLogic, any plates and associated statistics tables from PlateLogic, graphs, statistical analysis results, and data tables from GraphLogic, and elements from BeadLogic, having performed a multiplex analysis. To add elements to a report, simply highlight, drag, and drop. These can then be moved around the page and positioned accordingly. To import multiple elements, make the selection, drag, and drop. And in this case, if we wanted to distribute and align our different dot plots, I could select them, and using the icons in the toolbar, align and distribute evenly. To add graphs, I go to the GraphLogic tab, expand the tree, and click and drag our different elements directly to the page. Again, I can distribute and align. As mentioned, you could also drag and import the data table from which the graph is derived. To add a second page, click the icon in the page preview panel. And in this case, I'll add my plate overview of my analysis. So here we have a very simple two-page report. As mentioned, the page preview doubles as the formatting panel. So we saw in GraphLogic how we could click on different portions of the graph to change the attributes, and the same goes within DocLogic. So again, if I wanted to change the color of a bar in my bar graph, I could click within the bar and we see the same formatting options as appeared in GraphLogic. Now, if I return to GraphLogic, you can see that the update has been carried across all aspects of the program. Likewise, I could change the graph type, reposition labels, and even resize the graph itself. Now, if I wanted to copy these new settings to other related elements, I could select my graph and from the toolbar, choose Copy Selected Settings. I could then highlight my other graphs and paste the settings, or alternatively, I could paste the settings to all related elements within the selected documents. So here, as soon as I click this icon, all my graphs will be updated. The only elements that aren't updated when pasting the settings are the group colors and the graph labels, as we want it to be possible to copy settings between different graphs even if there are different numbers of groups, And of course, we don't want all graphs to be labeled the same, which would make them indistinguishable. The same goes for other elements in your report. So if you click within a dot plot, you can change the plot size and format the gate label text. You can also click on the dot plot labels and titles. So in this case, if I want to remove my title heading and even set the text size to 0 to make it disappear completely, I can now copy these settings and paste it to all dot plots in the selected report. Other elements that you may wish to add to your report include standard text boxes, tables, arrows, rectangles, or you could import a saved image. We can also add keyword text boxes. So this is a text box that will take the metadata from a particular file and add it to your report. To demonstrate this, I will firstly display all of my samples, then I will draw a keyword text box on my report, and I want to add metadata from my first sample. So here I'll select my sample, drag it into the keyword text box, and then I'm presented with all of the metadata contained within this file. I can then make a selection of keywords that are within this sample and then drag them into the keyword text box. So now we have a record showing exactly which sample these plots belong to. And these can be very useful if you are generating and applying global analysis templates, because when you apply your template to a new dataset, the metadata displayed in these keyword text boxes will update automatically to show the information for the current file. There are also some very useful grid settings. So here I will generate a new report, and if I wish to import the first 5 populations from every sample, I could make the selection in the file inspector for one sample, click the highlight level button above the toolbar, and then define my grid settings. So in this case, I'll do a 5 by 4 grid. And I'll also choose to add these samples to the grid as soon as I insert them into the document. Now I just need to drag and drop onto the page, and we will get our 5 by 4 grid. If I wanted to change the grid settings after adding them to the page, I will highlight the relevant pages, change the grid settings, and click Apply. And in this case, it will reduce the number of pages in my document accordingly. Of course, I could go the other way. I could select my pages and make it a 5 by 3 grid and click Apply. One possible problem that can arise if you are making a grid with very large dimensions, for example, a 12 by 8 to mirror a 96 well plate layout, is that long titles, whether it be the plot title or the axis labels, will then suddenly run into the adjoining plots. To account for this, we can use a zoom to fit option. This means that the whole image, including the text, is shrunk as a single image. So here, for demonstration purposes, if we wanted to convert this into a 12 by 8 grid, I would make my grid settings 12 by 8, click zoom to fit, highlight the relevant plots, and click Apply, and it will shrink the whole image, including the text. I also want to highlight one very useful export option, and that's to save as a PPTX file. And the benefit is that exported elements can then be ungrouped and edited within Microsoft PowerPoint. So once again, to keep things simple, I'll generate a new report, add a single plot to the page. In this case, I'll even make it larger. And then from here, with the report selected, I'll choose the Export Document icon, choose PPTX, and I'll save it to my desktop. And now if I open the PPTX file, we can see the page represents the view that we had in FlowLogic. But from here, we can click to select any portion of the plot itself. So you could move elements or even delete completely. If you right click, you have the option to ungroup, and you can see all of the individual elements that are exported in this format. So you can very easily remove every attribute from the plot except for the events themselves, and obviously align, reposition, and combine elements from other types of experiments or assays. And of course, one of the most powerful aspects of FlowLogic is that all elements remain linked. So now if we wanted to go back to gate logic, adjust the gate, all graphs and everything through to the report will be updated accordingly. So there's no need to go back and recreate all of your different analysis components. If you think you will be using the same analysis approach on repeated datasets, then you can save your analysis as a global analysis template. To save an analysis template, there are only a couple of considerations. That is, within gate logic, you only have one experiment folder. So in this case, I'll delete my empty experiment folder. And also be aware that an analysis template is specific for a certain number of files. So here, if I was going to repeat this experiment with a new set of 15 files, then in this case it would be appropriate to save my analysis as an analysis template. To do this, I'd right click on the folder, choose Save Template from a folder. Then when I re-import my files, I can right click on the folder and apply this template. And I will demonstrate this with a previously saved analysis template in a fresh instance of FlowLogic. So to apply my analysis template to a new dataset, I'll import my files, right click on the folder, choose Apply Template to Folders, choose the specific template, click Open, and you'll see within a few seconds my gates have been applied. Overlays and plates will have been generated. Within GraphLogic, graphs will have been created and statistical tests performed. And then in DocLogic, we have in this case one single report with two different pages. I could just as easily import a second dataset. This is a 96-well plate dataset. Right click, choose Apply Template, and choose the appropriate 96-well plate analysis template. This particular template contains two separate heat maps, and in DocLogic, two different single page reports. And once again, if we wish to adjust any gate within gate logic, all other elements in our analysis will update automatically. So you may have seen in applying this second template, we have some heat maps that have been created in plate logic. And to finish this webinar, I want to quickly demonstrate how easy it is to create heat maps within FlowLogic. So once again, I will start a new instance of FlowLogic. I will select the plate logic option from the Advanced Functions pull-up drawer and import my 96-well plate data. In this case, I will generate a new empty plate. By default, it takes the form of a 96-well plate, but within the plate side window, you can choose whichever dimensions suit your analysis. To analyze my files, I will add them all to a group, and in working on one sample, I will add a very quick gating hierarchy, and this could be considered a screening analysis, where we're looking for the samples with positive expression within this R2 gate. Now I can select my samples and drag them into a plate. Within the plate settings tab of the plate side drawer, I will change the well shape to fill. And then within the heat map settings, I will choose my specific population, and in this case, a different statistic. The heat map is automatically generated. However, if you wish to change the ranges for each row, you can turn off the automatic setting, right click and insert additional ranges. You can also change the color for the gradient from low to high by highlighting all of the rows, right clicking, choose gradient, choose a start, followed by an end color. If you wish to display the plots in the plate, you can right click, choose Show Plots, and this will be reflected upon changes in the workspace. So here we can view the histogram. Additionally, we can choose by right clicking Plots to show the wells with the heat map colors. Within the plate side window, we can also visualize the specific statistics for each well. And we can even color the cells in the statistics table or the values themselves to match the heat map colors. And of course, this will update in real time to any adjustment in the gates. So that brings me to the end of this demonstration. I hope it has been useful for you. If you want more detailed explanations on any of the other features within FlowLogic, please see our other demonstration videos. And if you have any questions, please don't hesitate to get in touch.